So differentiate sin inverse cos pi by 2. How will you differentiate it? So firstly we will rewrite the question, that is sin inverse cos p by 2, and we know that the value of the cos p by 2 is 0, so sin inverse 0. Value of sin inverse 0 is 0, so differentiation of 0 is 0. Sin inverse 0. Or in the second way is that you can write cos pi by 2 as a sin pi by 2 minus pi by 2, because sin pi by 2 minus theta is cos theta and theta is pi by 2, so that will be cos pi by 2. Means our changing these terms into this term is right. And we know that sin inverse sin theta is equal to theta, where theta is equal to pi by 2 minus pi by 2, so pi by 2 cancel, that will be 0, so differentiation of 0 is 0. So both way you will get the same answer. Just see it. This is so we know the from the inverse 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 rule. From inverse rule, sin inverse sin x is x, or if sin inverse sin theta, that in place of if there is theta, then that will be the theta. So sin inverse sin theta will be theta, sin inverse sin x will be x. So here sin inverse sin theta is pi by 2 minus pi by 2, so we will write like this, and the value of this will be 0, because this plus pi by 2 and this minus pi by 2 will be cancelled out, so this will result 0. So dy by dx will be 0. So this is the first order derivative, means you can also find the second order derivative, third order derivative, fourth order derivative, and so on. But in this chapter we will study only the first order derivative, that is dy by dx. Its second order derivative will be written as d square y by dx square. Just see how the second order derivative is written like this. And if you want to write the third order derivative, then put 3 in place of 2, so dx cube by dqy. And if you want to write the fourth order derivative, then write 4 in place of this 2, and so on. So in this way you can write note this can be written as a like this second order derivative can be written as a like this. Similarly, third order derivative can be written as a like this. So these are the short form of the writing. Another way of writing. In the short form, we will write like this. So that's all about this. We will proceed further now. This is the extra knowledge and this is the extra knowledge. So we will now proceeding ahead. Example, cos inverse cos x plus pi by 4. Differentiate it. How will you differentiate it? So just firstly we will apply the trigonometric formula, that is trigonometric inverse formula, which I have told you in previous chapter. So cos inverse cos is x. This cos inverse cos is x. So this cos inverse cos, this theta, suppose that this is theta, then that will be theta. So y will be equal to theta. So and theta is x plus pi by 4. So we will differentiate that. Just to see it. So simply this was the based on the simple formula, that is cos inverse cos x equal to x. So cos here, suppose that this is theta, then cos inverse cos theta will be theta, and this is in terms of x, means this function is in terms of x. So we will differentiate it with respect to x. So differentiating with respect to x, that dy by dx equal to ddx of this, so that will be 1, and this will be, since constant, so that will be 0. So 1 plus 0, that is 1, will be answer. Similarly, we will see the another question. Cos inverse sine cx plus d. Differentiate it. Differentiate it. Let us first see. So this is the question and we have to differentiate it. So this is cos inverse sine, and this expression, this is quadratic expression. So we know that cos inverse cos x is equal to x, and sin x can be written as a cos pi by 2 minus x, means this can be written as a like this. So suppose that this is a, if x, for a moment if we think that this is x, so this is a sin x, so in terms of cos this will be written like this. This is same things as this, and cos inverse cos x is x. Suppose that this is theta, then cos inverse cos theta will be theta. And now we'll differentiate this expression with respect to x, because this expression is in terms of x, so we will differentiate it with respect to x. So differentiating with respect to x, this will become to 0, and this will come as a 3ax square plus 2bx plus c. Just see it, a will come out, b will come out, c will come out, and d is constant, so 0. So this is 1, this is 2x, this is 3x square. So that's all about this. The answer is like this. The key working is here. This step is very important. Moving to the next question. Sin inverse x plus pi by 4 plus cos inverse x plus pi by 4 means differentiate this. So in solution, firstly we will rewrite the question. Note, if these are in these problems, if you don't know the formulas and the rules of the sin inverse, then you will not be able to solve the question easily. So as you know that sin inverse x plus cos inverse x equal to pi by 2, and so here if this is x, or suppose that this is theta, then sin inverse x plus cos inverse will be pi by 2. So for this the value of this will be pi by 2. Suppose that this is theta, then that value of this is pi by 2, not x, that is pi by 2. For any value of the angle here, whatever may be the angle of this, the value will be pi by 2. So now we will differentiate pi by 2 with respect to x. dy by dx equal to 0. That is the answer. Note, this is the constant term, so it is not necessary that you will differentiate it with respect to x. As when the here is pi by 2 is coming, you can also differentiate it with t, z and so on. Once with any variables you can differentiate it, because the term is no more containing either x term or t term or z terms, but it's only constant term. So that's why you can also calculate dy by dt, dy by dz, that will be equal to 0. The final answer will be 0, means differentiation of this constant term will be always 0. So that is finally ddx of y is equal to 0. The key step of this question is this line. Moving to the next question. Note, in this question everything is right, but the just see it, y equal to sin inverse t we will assume, then that will be sin inverse t, and differentiation of sin inverse t is in under root 1 minus t square. So here will be in under root 1 minus t square ddx of t. So, and putting it equal to under root x, so we'll differentiate it by just like this is x power n, where n is 1 by 2, so 1 by 2 x power 1 by 2 minus 1. It is just like a x power n differentiation. So doing like this you will get 1 by 2 under root x, but here will be in under root 1 minus x square, and this is under root, so that will be the 1 minus x in under root 1 minus x. Here should be in under root 1 minus x. Just improve yourself. The question is differentiate tan inverse plus tan inverse 1 by x. Then in this question, if you don't know the formula and rules of the tan inverse, means inverse, trigonometric inverse, then you will be hardly able to solve such a kinds of the questions. So in order to solve this question, you have to know the formula of tan inverse x plus tan inverse y, which is like this. So 1 minus x by 1 by x, because the formula of tan inverse x plus tan inverse y is tan inverse in bracket x plus y by 1 minus xy. So this is based on the same formula. So that is tan inverse infinity. So that is equal to pi by 2. Tan inverse infinity, that is equal to pi by 2. So the value of this is pi by 2. Here I am writing the formula so that you could not get any kind of the confusion. So very important formula. So that is tan inverse infinity, which is 90 degree, and hence pi by 2. So we will write here pi by 2 and differentiate y equal to pi by 2. That will be definitely 0. So that will be the 0. So that is the final answer. Now moving to the next question. So the question is y in under root 1 minus cos theta by 1 plus cos theta. So this 1 minus cos theta 1 plus cos theta can be written like this, because if you will break cos theta in terms of sin theta, then you will write 1 minus 2 sin square theta by 2. So 1 will cancel, and in numerator there will be only sin square theta by 2. Similarly, if you will break this cos into 2 cos square theta by 2 minus 1, then minus 1 and this 1 will be cancelled, so only 2 cos square theta by 2 will remain. So in numerator 2 sin square theta by 2, and in denominator there will be 2 cos square theta by 2. So 2 will cancel. So finally the term will remain sin square theta by 2 and cos square theta by 2. So sin square theta by 2 by cos square theta by 2 will be tan square theta by 2, which is this. So we'll write, and this will come like this. This under root will be removed, and now this term is in the function of theta, means this is a theta function. So you will not differentiate it with respect to x as you used to do generally in your previous question. So you will differentiate it with respect to theta, because your function is in terms of theta. So dy by d theta and dd theta tan theta by 2. So this is tan theta by 2. So finally we will write, so we will differentiate sec square theta by 2 into dd theta by 2. We will also differentiate this part. So finally this will come as a 1 by 2. So 1 by 2 times sec square theta by 2. So that is the final answer. Note: